NASA's supercomputers are about to take on one of the most dynamic and dangerous places in the world, an area near Greenland's most active glacier where over 200 billion gallons of meltwater gushes into the sea every day, enough to fill 189 million Olympic swimming pools or 75 billion bathtubs. That's a lot of water. And if it were your house, you might want to move away from the coast. It is here that the ice sheet that covers 80% of Greenland is thinning and accelerating at a rate that will raise global sea levels and threaten coastal communities around the world. To better understand how the ice sheet responds to warmer temperatures, NASA has deployed its cutting-edge supercomputers to simulate conditions in this extreme environment. This is a place where summer temperatures can reach nearly 50 degrees Fahrenheit, where winds can blow at hurricane speed, and where massive icebergs form, break off, and disappear into the dark depths below. It's a challenge unlike any other, but why does any of this matter? What makes this remote area so important to our planet, and why should we care about what happens there? The answer lies in understanding the delicate balance that keeps our planet habitable. Our climate is finely tuned for life as we know it. Temperatures must stay within a certain range for water to exist in liquid form, forming the basis for all life. Too hot and the water evaporates. Too cold and it freezes solid. But when Earth's temperature rises even slightly, the consequences can be catastrophic. Take, for example, the ice sheet that covers Greenland. This vast expanse of ice reflects sunlight back into space, keeping the planet cool. But as temperatures rise, the ice melts, exposing darker surfaces that absorb more sunlight and further heat the planet. This creates a dangerous feedback loop that could spiral out of control. Now let's talk about those supercomputers. These machines are like really smart, really powerful computers that help scientists solve big problems by doing a lot of math really fast. They crunch numbers and run simulations to help us understand things that are too complex or dangerous to study in real life. For example, they can simulate the behavior of the Greenland ice sheet under different conditions, helping us predict how it might respond to future changes in temperature. To do this, they use a lot of math, really complicated math. The Greenland ice sheet is a really big deal. It holds so much water that if it melted completely, sea levels would rise by more than 200 feet. That's more than the height of the Great Wall of China. And while that may sound like something that will happen only in a century or two, things are happening faster than we thought. Since the 1990s, the rate of ice loss in Greenland has increased by 250%. So these supercomputers are like the Sherlock Holmes of the scientific world. They sift through data, looking for clues to help us understand what's going on and make better predictions about what might happen in the future. For example, NASA's supercomputers have been used to study the impact of rising temperatures on the Greenland ice sheet. By running simulations, they can model how the ice sheet will respond to different temperature scenarios and help scientists better understand the risks of climate change. But it's not just about solving complex problems. These supercomputers also help us explore the unknown. For example, no human has ever explored the surface of Mars. It's a hostile environment with a thin atmosphere, freezing temperatures, and toxic soil. But that doesn't mean we can't explore it. With the help of rovers and orbiters, we have been able to map the surface of Mars and identify potential landing sites for future missions. And now we're reusing supercomputers to simulate what it would be like to land on Mars and explore its surface. These simulations can help us identify potential hazards and develop strategies for mitigating them, making it safer for future explorers. It is here that NASA's supercomputers come into play. These machines allow scientists to perform experiments that would be impossible or unethical to conduct in the real world. By simulating the behavior of the Greenland ice sheet under various conditions, researchers can gain valuable insights into how it might respond to future changes in temperature and precipitation. These simulations can help us better understand the risks of climate change and develop more effective strategies for mitigating them. For example, one simulation might involve creating a virtual twin of the Greenland ice sheet and then subjecting it to different temperature scenarios to see how it responds. Another simulation might involve tracking the movement of water through the ice sheet to better understand the processes that lead to melting and drainage. By running these simulations on a computer, scientists can study the behavior of the ice sheet, without having to wait centuries for it to respond in the real world. They can also vary the conditions of the simulation to test a wide range of scenarios and identify the most likely outcomes. One of the key advantages of using supercomputers for these simulations is that they allow researchers to study processes that occur over vast stretches of time and space. The Greenland ice sheet is so large and complex that it would be impossible to observe all of its processes at once. But with the help of supercomputers, scientists can virtually fly over the ice sheet and zoom in on specific areas of interest. They can also track the movement of individual molecules to gain a better understanding of the physical processes that govern the behavior of the ice sheet. Another advantage of using supercomputers is their ability to incorporate data from real-world observations into simulations. By combining computer models with real-world data, scientists can create more accurate and realistic simulations of the Greenland ice sheet and its behavior. This allows them to validate their simulations and ensure that they are accurately representing the complexity of the ice sheet. The results of these simulations are not only useful for understanding the behavior of the Greenland ice sheet, but also for predicting how it might respond to future changes in climate. By projecting future changes in temperature and precipitation onto computer models of the ice sheet, scientists can estimate how much melting and drainage is likely to occur in different regions. This information can help policymakers and communities develop more effective plans for managing the risks of climate change, such as rising sea levels and more extreme weather events. In addition to predicting the behavior of the Greenland ice sheet, NASA's supercomputers are also being used to study the impact of melting glaciers on ocean currents and weather patterns. As glaciers melt, they release vast amounts of fresh water into the ocean, which can disrupt the flow of ocean currents and affect weather patterns around the world. By simulating these processes, scientists can better understand the complex interactions between ice sheets, ocean currents, and the atmosphere, and better predict their impact on global climate patterns. So why should you care about NASA's simulations of glaciers and ice sheets? Well, as we said before, the Greenland ice sheet holds enough water to raise sea levels by more than 200 feet. And while that might sound like something that will happen only in a century or two, things are happening faster than we thought. The rate of ice loss in Greenland has increased by 250% since the 1990s. And according to some estimates, we could see sea levels rise by 1 to 9 feet by the year 2100. And it's not just about rising sea levels. Melting glaciers and ice sheets can also disrupt ocean currents and weather patterns, leading to more extreme weather events. In fact, the Intergovernmental Panel on Climate Change has already concluded that human-induced climate change is likely to continue causing more frequent and severe disruptions to the frequency, duration, and intensity of extreme weather and climate events in all regions during the 21st century. But it's not all doom and gloom. By understanding the risks posed by melting glaciers and ice sheets, we can take steps to mitigate them. NASA's supercomputers are helping us do just that by studying the behavior of glaciers and ice sheets under different climate scenarios. We can develop more effective strategies for reducing greenhouse gas emissions and slowing down the rate of ice loss. We can also use these simulations to better prepare for the impacts of sea level rise, such as by building seawalls and other coastal defenses. In conclusion, NASA's supercomputers are helping us better understand the behavior of glaciers and ice sheets, predict their response to future climate change, and develop more effective strategies for mitigating the risks posed by melting ice. These simulations are essential for protecting our planet and the people who live on it. If you enjoyed this video, be sure to check out our other videos on similar topics. And don't forget to subscribe to stay up to date on all of our latest content. Thanks for watching.